Welcome to the 6th video in this series, which describes the many features and functions of the Prestec Icon 100 press brake controller. In this video number 6 we discuss running a job from the various run screens available to the operator. In a way, this is the heart of the Icon 100 system, giving the operator ease of control in all aspects of the bending process. Let's just for a minute revisit the axis definitions via the Quick Start key on the home page. This is always available and has some items of use for a new operator especially. Here's where the axes are defined, and these names are also assigned to the axes as shown on the job screen. Access to the run screens is always available via the Run Job select key. Most jobs look like this. This job, the job here is shown as bend number 3. We'll just go back to bend number 1. These keys are colour coded. Green means that the entry was sourced from an operator input. Blue means that the entry data was sourced from an Icon 100 calculation. Both blue and green can be edited by the operator. Once they've been edited, then the system will cause that key to go green. We'll change that to say to 11. Grey means that the axis isn't available for some reason. At any time you can jump back to the edit screen and just make sure that you've got the right job going through the sequence. You understand what you're making, run back to the job. Also have a small item here which shows where you are in the job as you process through the bend sequence. Lime means that all of these axes are ready to run. If they turn violet, then it means that that axis is moving under icon control to a new set point position. Red means that an error has occurred, or that field is in error and must be cleared before moving into auto run mode. Typical errors such as emergency stop or axis over travel limits or incorrect data are always flagged in red, with the axis or axes that are being affected inhibited. For example, an emergency stop will look like this, with the movement axis inhibited and flagged in amber, and emergency stop being flagged in the main display. An X over travel limit switch firing would look like this, where this is shown that the x-axis is moved too far forward and the x-axis is being limited and inhibited until that error is cleared. A data error might look like this. If we tell the x-axis to go to -20, invalid data will occur, and in this case the job simply won't run at all. If there are any errors in any of the data fields, the job will not run, and the red flag is shown on the Run Job key. The run screens are presented in two forms: Screen S6.1 and, using the View key, S6.2. Notice S6.1 shows one bend and all aspects of that bend. S6.2 shows the job in a different form, 1, 2, 3 bends shown sequentially up to the 20 bends available in each bend sequence. The power of these screens to an operator is that anything can be changed quickly on screen while running the job. The operator is in complete control within the safe operating area of the machine tool as set by the parameters on the icon itself. The layout of the single bend page shows the parts data in the top left section of the screen. The top of die, the material gauge, the material itself, the top of die dimension, which is the value when the tip of the top tool touches the top of the die block. This value is set by tooling and other physical issues, but can be changed from the jog keys under calibrate modes. For this information, refer to video number 9. The millimetres per degree reading is a calculated close proximity to the depth of the top tool penetration into the V, equating to every 1 degree of bend. This value gives the operator an understanding of the precision of the work that he's doing. This value can be used for very fine tuning of the Y1 or Y2 axes. For example, to correct Y1 for a 1 degree underbend, simply add, in this case, since it's 0.05 of a millimetre per degree, to the Y1 set point. You change the Y1 set point to 86.62. We've just corrected a small 1 degree taper across the machine. We use the angle correction to correct both axes at the same time in decimals of degrees. So for example, if we wanted to correct by 1.2 degrees across both Y1 and Y2 axes, we'd say to make it 1.2 degrees more acute bend, we'd put in a negative 1.2. Notice both Y1 and Y2 axes moved by the appropriate dimension. Tonnage can be changed at any time, so to speak. This lower left mimic down here displays the orientation of the job as the job bending process proceeds. If we have a look at manually step through the job using these two keys over on the right here, you can see how in this case the job's been flipped over for step number 2, then flipped back again for step number 3. Across the top of the page here we have the present positions of the axes and their current conditions, in this case being all lime green. We're ready to run. Underneath those is this block of keys which relate to this particular bend number 1 and define the operations of the bend in all of its various aspects. The angle field is sourced from the drawing and is not normally edited. The correction field is best for small corrections on the job. The Icon 100 uses the included angle, so an entry of -1 would reduce the angle, making the tool penetrate deeper into the die block. The set points for Y1 and Y2 and X and R are all calculated by Icon as a result of the drawing originally set up in the design process. The opening is the clear open height from the material to the tip of the top tool. You can look at these open heights on the simulate screen. We'll just have a quick look now. The inner circle is the 50mm opening and the outer circle is 100mm opening. In this case we've got a 50mm opening. You can have whatever you like, of course, and those red circles give us an idea of how far the tool needs to retract up in order to get the part out during the bending process. Slow is normally calculated by Icon, but at a previous time in these demonstrations it's been modified from 10 to 11mm, and that indicates the distance from the material to when the pressing cycle starts. In this case 11mm above the material, the pressing cycle, the high pressure part of the stroke, will begin. Dwell is always on. The longer the dwell time is, of course, it's used mainly for assisting and mitigating spring back on high tensile or underbent jobs. Dwell can be changed to the trap function. The trap function can be easily set and is common, as is dwell, to all steps. select trap from the numeric keyboard. This function is very useful on big machines in particular, when materials handling of the part requires some manipulation, and it's desirable to have the top tool hold its position at bottom limit, thereby holding the material in place until certain other pieces of equipment can be laid into position. When the trap is set, the top tool will not retract until the up foot switch is tapped. Line bending is a very useful feature of the Icon system and facilitates the manual by eye alignment of a part with respect to the tip of the top tool. When set to on, Icon will cause the top tool to hold moving down approximately 1 millimeter or so above the material, thereby allowing the material to be aligned manually. Once done, then the process of bending can be completed by repressing the down foot switch. Delay being set to on is useful with respect to the x-axis. It's an x-axis command and will cause the x-axis to hold its position until after the bend is completed without repositioning itself to the next step until the up foot switch is tapped. The drop-down numeric keyboard has extra functions when applying data to these fields. The recalculate button, if we have a look at this Y1 which was originally edited, this recalculate button here, if pressed, will cause Y1 to resume its original value, and as it should do, the field turns back to blue again because it's a calculated field. The copy all function is very useful with corrections, for example. You can make a correction that applies only to the same angle throughout the job. In this case, we'll make a 1 degree correction to copy same, which means it will have a 1 degree correction on bend number 1 at angle 135, a 0 correction on the 90 degree bend, and on the 135 we'll have on the next bend 3 135 we'll have the 1 degree correction again. Okay, we're now ready to run the job. We're going to start to run this job in bend number 1, and we start to run by pressing the Run Job key. We notice that the axes begin to set themselves up as they should, with R and X following the appropriate logic sequencing. I've got step 1 set up with a 3 seconds of dwell. Bend 2 has got line bending turned on, and bend 3 has got delay turned on. So in each case we'll have a look at how these particular attributes change the functioning of the bend sequence. I'm going to press the foot switch down now, and you'll see the machine come down, indicated by the violet colours, and now going back to top of stroke and X repositioning itself as it should, and we're set up with bend number 2 ready to be done. Once again, we're going to come down, and we should stop just above the material and wait until we manually align the material with the tip of the top tool. Okay, we've stopped and we're lining up, and now we can go back down again to the bottom limit, going back up. Executing bend number 3, you come down, thanks for watching.